All right. So,
Thank you.
let me just update a couple of things here. So this is going to be a credit card array. All right, so we're going to do this for credit cards first. Actually, I'll probably only do it for credit cards, and then you guys can do it for the other one. All right, so pretend like you didn't see what I just did. I'm going to be going through it and explaining it in a few minutes. So what I'm going to do is I'm going to go into my layout, and what I'm going to do here is I want to create a special row for showing credit cards instead of just a string. I want to show an actual credit card object, okay? And when we looked at this, we decided that, well, what's a credit card? Like a name, a start date, a minimum spend, and a point bonus. So let's say that maybe we put name and start date on one line, and maybe minimum spend and point bonus on another. So it's a more complex layout, but not incredibly whatever. We don't have pictures and animations and stuff like that. But instead of there just being a single string, we'll have 4 individual pieces of information, 2 here, 2 below it. Okay, and that's what an individual row will look like. So to pull this off, I'm going to go to my ResLayout. I'm going to right click. I'm going to say I'm on a new, where's my layout file? Layout resource file, this guy right here. All right, and I'm going to change the top level thing here to be Android.widget. Well, let me do that. Let's go with it. So I want it to be a linear layout instead of a constraint layout. Usually, I think it's Android.widget.linear layout, but it seemed to be okay with that. So we're going to call this guy custom credit card row, and it has to be all lowercase. All right, and then I'll hit OK. And this is going to give me a row that looks like this. Oh, it did work, just linear layout. All right, so now what I can do is I can go ahead, so I don't have a constraint layout now, I just have a vertical layout, which I prefer that anyways. So what I'm going to do is I'm going to put, just so I can kind of have a grid, I'm going to put a horizontal linear layout and then put 2 text views in there. And then I'll put another horizontal linear layout with 2 text views in there. So here's one horizontal linear layout. Here's another horizontal linear layout. The first one, I'll put a text view in. Then I'll put another text view in there. So it lays those guys out next to each other. Then I'll do the same thing here. And the same thing here. All right. Now, this linear layout, the reason it's currently off the screen is because its height is set to match parent. We're going to change its height to wrap content. So that means it'll only wrap around the text views that are in there. I'll do the same thing with the other one. Okay. So now I'm going to go ahead and give these guys some names. So it's a name, start date, minimum spend, point bonus. So this will be name. Let's call this guy CC name. Text view. this will be, and I'm going to take the text out. Actually, I'm going to leave the text in for now just so we can see what it'll look like. We're going to be overwriting it anyways. Say this guy is going to be CC expiration date, TV. Just say expires. This guy will be CC min spend, TV. And this guy will be CC bonus points, TV. Okay. So that's what that guy will look like. I could actually make these guys all be even, but this looks pretty enough as it is. So let's just leave it like that. Makes it look custom, whatever. All right, so I gave these guys all names. So now when we fill in a row for a credit card, it's not just going to be a string representation for that credit card. We want it to put the name of the credit card here, the expiration date here, the minimum spend here, and then this guy is bonus points. Bonus points here. All right, so much more customizable than what a default array adapter can pull off. All right, now let's just go back here and we'll put a little context as to what is an array adapter. An array adapter adapts well, let's say a collection of objects to as far as we're concerned right now, it adapts it for a list view. But it's not limited to just list views. Say this adapts a collection of objects to a list view. Now, what does this ultimately mean? Let's draw a picture here. All right, so we have our list view over here. Then we have our array. We'll just use our array of credit cards as an example. And of course, that is green. All right, so now this guy here is filled up with a whole bunch of credit card objects. I ultimately want these credit card objects to show up in my list view as individual rows. A default list view doesn't know what the heck a credit card object is. It wasn't around when this guy was, credit card objects weren't around when list views were originally written back in the early days of Android, whatever. Okay, so this guy doesn't know how to show these guys. So that's where we need a dude in the middle. That's our array adapter, which of course is pink. Or was magenta? Oh, whatever. All right, so this guy, the default array adapter, knows how to take a collection of strings and put it into a list view. Well, now I have a collection of objects. So I need to write my own custom array adapter that knows how to take these kind of objects and map them to the rows in this list view. Does that make sense? That's why an array adapter needs us to give it what the row looks like. So if you look back at our code here, we go into, where is it, main something? When we're creating our array adapter, we say, here's the activity where this is happening. Here's what my row looks like. That's my layout. And then here's the collection of things I want you to put into that row. Go ahead.
So I was actually curious about this. So when we do new array adapters, like in default, it can only ever accept a text view. So when we make the layout XML file, that would always have to be just a single text view that we're giving to it if we're not
doing something special.
Okay.
Yeah. But the reality is you would probably almost always do something special. And when you don't, you probably wouldn't create a layout the way we did. There's a built-in like single row for strings layout that I just didn't use. But I wanted us to get used to creating the XML layout thing. But if you want a very generic list view, then you can use the built-in, it's just a text view row. All right, so notice an array adapter takes these three things: the context, what the row looks like, so this is the view, and then the collection of things we want to adapt to that view. Make sense what an array adapter does now? It adapts a collection to a view. Or adapts a view to the collection. I think it's the other way around. Adapts a collection to the view. Takes the pieces, squeezes them into the view. All right, so if we're going to make our own array adapter, let me go and show you the documentation for ArrayAdapter here. So a default array adapter, here's an array adapter here. So this guy extends something called a base adapter, whatever, so that's some other adapter. So in the object-oriented hierarchy, it's an object, then it's a base adapter, and then it's an array adapter. And technically an array adapter is of a certain type, and that'll kind of make some sense here in a few minutes, since we're going to have our array adapter work on a type of credit cards. Okay? Now, there is one really important function inside of ArrayAdapter that does all the magic for us. There's multiple other functions that may be important if you want to like respond to clicking on things and stuff like that. But the important function for us is a function called GetView. This guy right here. This guy gets a view that displays the data at the specified position in the data set. So an array adapter, when we're trying to show row 7, for example, the array adapter will have this function called with row 7 passed to it, along with the layout that we're supposed to put row 7 into. That makes sense? And so my GetView, the default version of GetView, takes a string that lives at this position and shoves it into this text view. It assumes this guy's always a text view. Okay? But in our world here, he's not just a text view. In our case, we actually have 4 text views. So we're going to need to write our own version of GetView in order to have a specialized array adapter that knows how to put credit card objects into a specialized row. Make sense? All right, so let me show you the code for doing this.
It always makes sense until I try it myself.
Well, let's hope I can do it. Gotta blink it out here. All right, we're back. Where's my adapter? Here's my adapter. You're laughing at me. I can't see large percentages of the day, so it doesn't matter. This is not. All right, the font's too small in this. I need like, grandpa font, bigger. What sucks is, oh yeah, there we go.
You have to scroll to the side.
Okay, what was it? Oh, my array adapter. Okay, so I'm going to create my own array adapter. I'm calling this guy a credit card array adapter, and he is extending an array adapter. So when we say something extends something else, this is the object-oriented model for inheritance. So my new dude right here, my credit card array adapter that I am inventing right now, he starts off as a plain Jane array adapter. That's what he is by default. Okay? Now, I didn't need to store these variables up here like I did. I could have relied on how an array adapter actually works, and I'll kind of talk about how this works as we get into it. But for right now, I'm just going to store 3 pieces of information up here. I have my context, I have my collection of credit cards, and I have my text view resource ID. So that's like the r.layout. My special row thing, whatever we called it. All right, that makes sense? Okay. Now, the reality is we don't have to set this equal to new there. I think that was a comment before as I was fixing this stuff. Okay, so I have 3 fields that are going to be equal to some stuff. All right. Now, my credit card array adapter is going to take in 3 pieces of information. It takes in a context, it takes an int representation of the resource ID, and it takes in our collection. Just as a reminder, here's my plain Jane array adapter. What does this guy take in? He takes in a context, he takes in a resource ID, and he takes in a collection of objects. This is just one of the several constructors, but this is the one I'm using. All right, so a normal array adapter requires those 3 things to work.
Is this an example of polymorphism?
Well, having all of these constructors that take different numbers and or types of parameters is an example of polymorphism. Okay, but in our case here, the constructor that we intend to use for our array adapter is this guy here because we're still operating with arrays. Nothing better than arrays yet, or newer than arrays. Okay, so we have our array adapter, and this guy takes a context, a resource ID, which is an integer, and then our array. This is the constructor for array adapter. Credit card array adapter is a array adapter. He's one of those kind of animals. Okay? So the constructor I write for credit card adapter, this guy can take whatever I want. But when I first build him, I want to build him in terms of a generic array adapter first. That's what this very first line is doing. I'm saying I want to call upon my parent's constructor. Super. It has to be the very first line in the, when you work with inheritance here. So extends equals inheritance. So this guy will be an instance of one of these guys and then potentially something more. We're going to make him more. If you want to rely on your parent's constructor to do some of the initial building, we have to put that as the very first line. Okay? And this is similar to what we did here in our loyalty program dealie. So loyalty program, we had 2 different constructors, and one of them was built in terms of the other one. So instead of it being built in terms of his parent's constructor, he was built in terms of one of his own constructors. That's why we said this there instead of super, which goes up to the parent. There. All right, so the very first thing I'm going to do is I took in those 3 pieces of information because that's what a default array adapter needs. So the very first thing I do before I do anything else is I go ahead and say, here, parent, here's the 3 pieces of information you want. You want a context, you want a resource ID, and then you want a list of stuff. Okay? Now, I can go and look inside of my array adapter, and I can look at the getters and setters and see how do I get the, like the get collection or get array or something like that. There's functions to get at those individual values, but rather than rely on that, what I just said is I'll let you do any sort of special setup you need to do to make yourself an array adapter, and then I'll just go ahead and remember those 3 parameters myself, just in case I need them. Okay? So, now, every single time we go to show a particular row in our list view, this GetView function will get called. Remember, the default GetView function for array adapters puts a string into a text view. That's what it does. I need to do something a little bit more custom here. So I'm overriding this guy. Now, I'll just show you how you can accomplish this. It won't let me do GetView again, but if I do something like getItem. So let's pretend like I was overriding getItem. If I press enter on that guy, notice it goes ahead and puts in all the code for me and puts the little override thing before it. This override thing is not required. It's a performance enhancement. So it allows, I think this is actually a Java thing that it will tell, related to object-orientedness, that will tell Java not to even look at the parent for this function. You're creating a more local copy. It'll make it a little faster. All right, but Whether that's there or not, it put it there for me. I would probably never waste my time typing it if I was typing it myself, but most of the time, if I know that there's a function that already does something, here, like here, there's our get text view resource. So that's how we could have gotten at our text view resource. So we actually didn't need to store this guy up here if we didn't want to. We could also get the context. We didn't need to store that guy if we didn't want to. Things like that. But I'm storing them locally, so I didn't have to go and look at that stuff. And there's our array. That's the way we can get our list too. All right, but if any of these guys, if I want to override them, I just go and find the guy that, oh yeah, I want my own version of him. Just press enter on it, and it'll go ahead and put the method header in there. And the very first thing it does is it will call upon the parent's version of that. So you might want to rely on the parent to do something, and then maybe you do something a little bit more. Okay? But the only thing we're going to change is GetView. So understand that I already went through and found GetView and pressed enter, and it gave me this thing here. So GetView ultimately returns a view. So the job of GetView is to return the view that is the row at position with, in our case here, all the credit card information already set in there. So build a view, stick the stuff where you want it to, hand the view off. That's this guy's job. Okay? And this guy comes in, so he gets a position. He comes in with the view itself. And then we also have access to our ViewGroupParent in case it's of interest to us. So in this case, this would be the actual ListView, would be the ViewGroupParent for this guy. Remember earlier I said array adapters are used for list views, but they're actually used for other things as well. Here's your evidence of that is our parent won't always be a list view. It could be other things as well that we use array adapters for. But in our little world right now, it's for list views, okay? Because what we're looking at in here is not necessarily Android programming. We're looking at advanced programming topics. We just happen to be using Android. So we'll build all our apps in terms of the little widgets and tools that we have in our toolbox in front of them, which every week should get a little bit bigger, right? But we're not going to learn the entire Android language. So at some point, we might bump into something where we'll use an array adapter for something else, like a recycler view or something like that. But right now, they're only used for list views. That's just how the world works. All right? So this is our parent. If we care about it, this would be the list view in our case here. This is the view associated with our actual row. And then this is the position in my array of credit cards that I'm trying to put into this row. All right, so far so good? All right, now the very first thing here, this is a little bit of, I don't know, let's call it somewhat of a waste of time. This guy's already a view called convert view. I don't know why we're putting it into another variable. I took some other code, just adapted it, but whatever. It's not hurting anybody. But this first thing here is kind of interesting. So we go ahead and we put it, notice this thing says it's nullable. What that means is it's possible for that value to be null. Again, I would rarely write things like this. If it got auto-created when I was typing something, I would put it in there, but that's what this placeholder ultimately says. It says that it's possible for this value right here to be a null value. Therefore, we probably need to check to see if it's null before we start shoving credit card pieces of information into it, right? If I have a row that is nothingness, I don't want to start sticking credit card names in there because I don't have anything. It's just going to fall into the void, and then I'll get a null pointer exception and all that jazz. Okay, so I have my view here. I'm calling it something called list item. Maybe that's a little bit friendlier thing to call it because it's a item in our list view, a list item. Okay, but then I ask the question, is this guy null? Now, under what circumstance might it be null? This goes back, and the evidence is that they've actually improved upon this even more, and that's why list views are older technology for Android. They still work, but the new way of doing it is through something called a recycler view. I can show you an example at some point of a recycler view. I wrote one recently, but it's significantly harder to teach. So I think list views accomplish what we need them to accomplish without overly making it more complex than it needs to be right now. All right, so, but the idea here is why might this list item, why might the view that we're trying to fill in, the row, why might it be null? And the idea is, let's say you have a list view that has 10 elements in it. Well, I'll ask this question first. Does anybody happen to know why it could be null? It's a performance, it's really a memory issue that they're solving. So let's say that we built a list view that had really, really, really complex rows. You know, like our super 4 text view rows, right? Okay, and let's say there's 1,000 elements in our list view. Do you think it would be wise to have 1,000 physical instances of each of those rows? Or do we just need enough rows to cover whatever's not on the screen so that when we swipe, we could fill in the difference real quick as it scrolls through? So if we only show 10 rows on the screen at once, maybe only 14 rows actually exist. So just on the outskirts, as we start scrolling, it fills in the next guy down. And whatever just scrolled up off the top of the screen there drops down to become the next guy. Make sense? So we're reusing those rows. So it allows us, so we're relying on the processor of the phone to be quick enough that it can keep up and call this code quite quick enough, but we're using less memory and we don't have 1,000 rows instantiated when we're only showing 10 at a time. So we just need enough extra on the edges to fake the user out, right? So when this GetView gets called for a particular position, if it's a position that we've never shown before, so maybe the very first time through we're only showing the 10 rows, it's the first time through for all those. So it will likely be null. And when it's null, what are we going to do? We're going to make it not null. I'll talk about this in a second. But in the future, as we're scrolling through and scrolling around in here, we might come into a situation where it actually already is something other than null. That means it's a previously created row that I can now reuse to put my new credit card stuff in. So it says something about some other credit card, but before this guy goes onto the screen, I want to shove information related to credit card position into it. Make sense? All right. So this is where I kind of like some of Google's approaches to some of these things. So I want you to imagine at like a circus. You got that really creepy clown that does the balloon animals, right? So the way this works in Android is we have this thing called a layout inflator. So we want to think about our layout file, that r.layout. Whatever we named it. Think of it like an unblown up balloon, all right? And the layout inflator is our clown. So he's going to blow this guy up in terms of our current context. All right, so he's blowing it up in the current activity. That's what he's doing here. He's inflating. So he's saying, the clown walks up. He, I guess we're saying he's going to walk into a little room that looks like an activity to blow this up because it's a very secret activity, I guess. Then he's going to inflate that balloon. What's he inflating? He's inflating this resource ID, which would be something like r.layout.mySpecialRow.xml. Inside of the parent view group, so this will be inside of my, in this case, list view. And then this thing attached to root for false, that's if you have more complex parent groups where you may or may not want something to be a unmovable child of the parent view group. Not something we're going to have an example of right now, but that's where this attached to root thing comes from. So for us, it's always going to be false because we want our rows to be free-flowing. We can scroll through. Okay, so this guy's a clown. He's going to blow up a balloon. What balloon? This guy right here. Okay, and that is ultimately what we get stuck into list item, is the inflated view that has our 4 text views in it in this case. Make sense? All right, so when we get to this line right here, we definitely have a real list item. We either just had the clown blow it up, or we got a balloon we're supposed to reuse. One of the two. Okay? But when we get here, we definitely have an actual list item. Now, I'm going to go ahead and grab my 4 text views from this list item, very similarly to what we've done before. Before, we've always said this dot find view by ID because we're usually asking our activity to find a view within himself that has a certain ID. In this case, I'm asking my list item to give me something. So I'm going to have a text view, and we'll call it, we're doing credit cards, right? We'll call this guy CCName, and this guy will be the text view version of list item dot find view by ID r dot ID dot, and this is going to be called, what did we name this guy? CCName TV. Text view, and we'll call this guy CCXP. This is going to be a text view, list item, find view by ID, r.id.cc expiration date, text view, CC, was it minimum spend? Is equal to the text view version of list item dot find view by ID r.id.cc min spend. Text view CC, was it bonus points? Equals text view version of list item dot find item by ID r.id.cc bonus points TV. All right, so I've grabbed my 4 text views. It's not any different than what we've been doing inside of onCreated and activity. We're just asking a different context to get us our text views. We're asking our list item to get it for us instead of the content view of activity. All right, now that I have these 4 text views, I can just fill them up. So I happen to be working with my collection at position. So just to throw this in a variable as well, I'll say we're going to have a credit card, CC, and this is going to be this dot credit card list at bucket position. So I'll go ahead and grab the credit card that lives at position inside of my list of credit cards. All right, so CC is an instance of one of these dudes. Okay, now, right now, I want to have access to these variables up here. They're all private. So when something is private, what does that say? It says it's only accessible inside of the class in which it's defined. Again, not a Java thing. This is an object-oriented programming thing. Same rule applies for C#, Objective-C, C++. Private variables are only available inside the class in which they were defined. Public variables are available everywhere. Now, but if I make these guys public, that means somebody outside of this class could actually change the name of this credit card. So what I want to do is I want to give myself read-only access to this guy right now. All right, and the way we do that is we have these private members, and we're going to write getters for these. That is public functions for getting those values. So for example, I can say public string GetName, and this guy will return this dot name. So this guy is a public function, so I'm allowed to call him from outside of this class. It's going to return a string. The name is GetName. And he can come in if you'd like. Yeah, you sure? Yeah, it's not going to bother me one bit. So it's called GetName, returns a string, and just happens to return this private member. Okay? So we can write 4 of these if we want, but that could start getting pretty tedious, right? Most of our modern IDEs, like Android Studio here, have the built-in ability to generate these guys. So I can right-click here, and I can say, go to, should somewhere say generate. click on that. And here's all sorts of things I can generate. The one I care about is a getter. So getters allow us to get private information. Setters allow us to set private fields. I want to create getters. And now it's asking me, what do we want a getter for? Well, I want it for all these guys. So I'll just highlight them all, hit OK, and it'll build me 4 getters. Okay? Now, we could have written these by hand, no problem, right? There's nothing special about that code. It just saved us 2 minutes or something like that. But that adds up over time.
2 minutes for you, that's like 2 hours for me.
Well, it saved you 2 minutes if you knew what you were writing, if you knew the exact function you were writing. But to your point, though, this could be dangerous, though, because you don't want to just say, oh, I'm going to use this dropdown to give me the magical getters. Why? Because it just works. You want to understand why it works. Here's my GetName outside of where they put their curly brace. This is the same function I just wrote, right? Public returns a string called GetName. You can call it whatever you want. We can call it, say, GetElephant. It just might be kind of hard to use because now we have this weird method called GetElephant that happens to return the credit card's name. You know, it does the right thing. It's just misleading. Okay, but I called it GetName because that makes pretty good sense for getting the name variable. It's not going to take any parameters, and it's just going to return that variable. In fact, I probably wouldn't have written it this way. I would have written it this.name, so I wouldn't misspell name. But why do I not have to put this in front of here? This is kind of a quiz based on something I've taught today in class. Why is the this dot optional here? Context, good. We're in a non-static context here, right? Or an instance context. If we're in an instance context, this dot is assumed to be there. So it's not necessary. It's never wrong. And I like typing it, so I won't misspell things. But if you misspell the word this, then you have problems. All right, so pretty helpful for the generating getters thing. I call this, like, I don't know, syntactic sugar or something like that. It makes your life a little bit easier to be able to generate those things quickly, but I mean, don't rely on power tools until you appreciate what they're doing for you. It's kind of the punchline. All right, so what did I just do there? I have a whole bunch, I have 4 private fields, and I have now given myself read-only access to them. I can't change them from outside of this class, but I can get the values of them from outside of this class now. Okay? And now I'm going to go and use these functions I just built. So I'm going to go into my, where's my adapter? X-ray vision. There we go. Got it. Nailed it. All right, so this guy right here, CC. So I'm going to go ahead and I'm going to say ccname.setText. And the text I'm going to put in there is cc.getName. That's the name of my credit card. And I'm going to say cc expiration date dot set text is equal to cc.get start date. Oh, it was start date, not expiration date? Yeah, that's what it was. It was a start date, not expiration date. So I'm going to go in here real quick. I'm going to change my little expiration thing to not be CC expiration date. Instead, it's going to be CC start date. And I'll just put the word in here to say start date so we know what that means. Was testing you, and whoever let me type that without yelling at me fails. Who's taking credit for that? Shoddy?
That's me.
That's all you. All right, so we have our CC start date there now. So that should be generating, it depends how fast it updates, but it should be generating an error in here, and it does. So now I can say r.id.cc start date. There we go. And probably name this guy a little bit better name. Then we can say cc start date is equal to cc get start date. All right, so I just made naming convention better there in the last 30 seconds because I had a misleading name because of shoddy. All right, so now we'll do CC min spend. And this guy is we're going to set the text for that text view equal to cc.get min spend. Now, this guy is actually an int. All right, and let me show you, this is a kind of common problem people run into with Android. Right now, you look at that line of code and you say, oh, it must be fine because no red squiggly, right? This code is actually probably going to cause the program to crash. The reason for it, I'll show it to you for the next one. CC bonus points dot SetText. So notice here, I have a bunch of different versions of SetText here. And as you pointed out, this is an example of polymorphism. Same method with the same name, but the different number and or types of parameters. Well, look at the one of these that just takes a single integer as a parameter. That's what I passed up above. Right here, this guy is an int. So I'm calling the version of SetText that takes just an int as a parameter. And what that int is the resource ID of a string. There is a file over here called strings.xml. It's in values, yeah, strings.xml. So I can store, a lot of times this is for like multiple languages. So I can store like the title for 5 or 6 different languages inside of there, and then I can grab the resource ID for that. So I'm giving it an integer that is the minimum spend. So let's say that's 3,000. So in that case, I'm crossing my fingers and hoping that there is a resource ID equal to 3,000. Otherwise, my program crashes. That makes sense? I really want the number 3,000 to be in there. So I'll just turn it into a string. Okay? This is one of the most powerful moves you can do in Java. Empty string concatenated with an int, a char, or whatever. Java is a string-based language. C# works like this as well. You can turn any primitive type into a string by just concatenating the empty string onto it. This is a string that holds nothing. It is a string with 0 length. I am concatenating onto that string whatever this integer is. What will I be left with? I will be left with a string containing that integer.
So in my code, I went ahead and imported Java util date because I wanted to play with the date type. So I'm getting an error right now as I'm following along for the same reason because I'm trying to set text with the date. So if I do this, let's try. This should cast it to a string.
Yeah, well, it's not casting it. You're building a string.
Okay.
Yeah, casting would look like this. Well, if I was trying to cast this to a string, this won't work in Java. I would do that.
Okay.
So syntax for casting something is parenthesis, the type you're casting it to, close parenthesis, and then the value you're casting.
So that's what we're doing up above with the text views. We're casting those text views.
Yeah, because this guy, exactly. This guy comes out of here. I'll just show you an example below. If I say list item dot find view by ID, this guy will come back. Actually, it just shows a type T. So actually, that right there is evidence that I didn't actually have to do this.
Okay.
Historically, it would return a generic view. So I know that this guy is a text view. So I'm converting it to a text view, but actually I wouldn't have to because it's coming out as whatever type it actually is. Yeah, T means actual type.
Okay.
Yeah, so I'm being extremely explicit here is what I'm doing. In fact, this might even be giving me a warning for that. It's possible I can go somewhere and find it's giving me a warning that this is redundant. Yeah, so some of the things I might type is left over from, Android version 1, which was a horrible development experience. Android Studio is so much better. Android Studio didn't even exist back then. You had just Eclipse with an Android plugin. It was not good.
Could you also do so since you're having to convert that into a string, could you also do .toString, or does that not work?
Well, this doesn't work at all right now. So
Right.
you mean if I do this?
Yeah, instead of the concatenating that, could you do cc.getmin spend?
No.
You couldn't do anything?
No. Well, and here's a good reason for it. So the follow would be why. What kind of value is this guy? So we need to go look at the getMinSpend function inside a credit card. GetMinSpend returns that kind of value, an int. That's an int primitive type. Primitive types are very simple type variables. All they can do is hold a value. That's it. All right? So that means, so a primitive type is not an object type. So with that in mind, if I come back here, I can't say dot anything on this. Because it's a primitive type. Okay. Notice actually here you're seeing under Java's hood a little bit. You're seeing how they've implemented their primitive types in a purely object-oriented language. So you're actually seeing that in order to get the value out of this, you actually have an argument guy here that you can call, but notice it just boils down to himself. So you're actually seeing it unwind a little bit under the hood, but this guy is a plain Jane dude. You can't say dot anything here. Okay? But now, if I turn it into a string, let's just say this was the empty string concatenated with a 3000, like that. Now he's the string 3000. Now he's an actual string, so I can call that length on that guy.
Okay.
Make sense? Because he's now an object. I've converted him into a string. But I didn't cast him to a string. I built a string through concatenation.
Okay.
All right? So this plus sign here is the concatenation operator. What it allows me to do is it allows me to build strings. So I know you think the plus sign is the math operator for addition. It usually is, but if at least one of the two sides is a string, it's treated as concatenation. And what does that mean? It means glue this onto this.
So what other primitive types does, like, if you concatenate any primitive type with a string, it'll make it into a string?
So
Okay.
that's the char B. That'll make us the string B.
Huh.
Yeah. Java's really powerful when it comes to strings. So C#. So usually when I first start teaching Java as a language, we talk about how Java is a string-based language. Now, again, something I want to continue to focus on in here, we happen to be using Java in here. So I'm going to expect you to solve problems in terms of the tools I've given to you or the things that could be like easily found through a Google search or something like that. Okay? We're not necessarily learning Java in here. But like the question you're asking right now goes across the board in almost every object-oriented language. Well, that's actually not even a fair statement. Java and C# both share that powerful string affinity. Surprisingly, a very, very, very modern language that does not is Swift. Strings are incredibly unfriendly in Swift. They're difficult to work with. You have to, the reason is that they're implemented for performance under the hood. And because of that, the underlying data structure that strings are built on top of is less malleable. It's not as flexible. I would call it a problem, to be honest. I mean, manipulating strings like this is a pretty common thing, and Swift making it difficult to manipulate strings is, I think, detrimental to the language. You can make it work, but then you have to write all these helper functions. So then what do you do as a Swift developer? You basically write your own core, write your own singleton, and throw a whole bunch of string helper functions up there. That way you only have to write them one time, and then you just, that singleton travels with you from project to project to project, so whenever you need to do something with strings, you're relying on your own little libraries you wrote instead of it being built into the language. Okay. Make sense? Okay, so, good.
Did you not typecast the get function to be a string by default?
This guy? Well, yeah, I mean, we can. You can come in here, I mean, he wants to go onto this side and have that guy return a string there, and then do that.
So you have to throw the concat.
Yeah, I got to do. I mean, somewhere I got to do it.
So making it a.
It doesn't.
Yeah. All day long, that dude's an int. So if I want him to be a string at some point, I got to turn him into a string somewhere.
Okay.
I can hide it. You know, I can do it in here and hide it. Maybe the disadvantage to doing that is at some point in another part of the program, I might want to do math with this guy.
What's the term they use in language? Strongly typed language, or like JavaScript doesn't necessarily care what the variables are,
What the types are.
Yeah,
So
what the types are.
yeah, I mean that's right. So this is a strongly typed language where we always have to define what type we're putting in this variable. Where in JavaScript you just put var in front of it. You define it as a variable, but not the type. Python is the same way. Ruby's the same way. Almost all of our web languages are loosely typed, interpreted languages, which makes them natively slower because they're interpreted, and also the types require something called a type inference engine.
Okay, but if you're boiling down to bytecode, there's not going to be a loosely typed variable anywhere. Like this, because you know it's an interpreter, whereas this is a virtual machine. You run Java in the virtual machine.
Well, right, but your interpreters are going to be written in a high-level, strongly typed language. So it's going to bytecode one way or another. Just depends on what level you're hiding it. Yeah, so languages like JavaScript, they're heavily, I mean, they rely on the browser to interpret them. Browser is written in you know, C++ or something like that. So, you know, at some level, you're operating at a low-level language.
Zeros and ones are there somewhere.
Absolutely. Just how many weird little Rubik's Cubes did you have to go through before you got to it? All right, so we'll leave that guy as an int there. We'll change it back to an int here. And we'll do our conversion external to it just in case we ever do need that guy numerically. But we still could get him numerically by using our integer.parseInt to juice it.
Right.
You know, so. But if we're following good programming practice, we would probably say that if it is supposed to be an int, make it an int. And only turn it into a string when it needs to be, like we're displaying the value now.
Can you make multiple get functions for it?
Yeah, you could, as long as they don't share the same name. Yeah, so what you want to do here, maybe, is you want to say something like public string get min spend. Like that? Yeah, notice that these guys, it thinks they're the same. Because polymorphism says it's a function with the same name with a different name function with the same name with a different number and or type of parameters. Doesn't say anything about the return type. So from Java and any object-oriented languages perspective, even though both of these guys are called get min spend and neither of them take any parameters, just because one of them returns a string and the other one returns an int, Java views these as the same function. Okay? And that's not a choice. That makes sense. Why? Because the compiler itself, when you go to write this code, it's going to determine which version of a function you're calling based on what parameters you pass it. Right? It's not going to be able to differentiate between get min spend that takes no parameters and get min spend that takes no parameters to determine which of these two it should call. Right. Should it be spitting out an int or should it be spitting out a string? I mean, you could just do a little thing like add string. Now, so you can do that and just say, well, that's how you get the string version of it.
Right.
You know, so it all comes down to where you hide it. All right, so I took my min spend and I just turned it into a string here. I'll do something similar here. I'll do empty string concatenated with cc.getPointBonus. That's for my point bonus. So what have I done here inside of this GetView? I've inflated the view if necessary. I've grabbed my 4 text views. I've grabbed my credit card from bucket position in my list. And then I filled in those 4 text views with the values I want to have in there. Ultimately then, I'm returning my list item. That is the view. All right, so now if I go back here to main, where's main? When I do my adapter for my credit card, okay, that's this guy right here, I'm going to say, we'll go ahead and put this up in core too, just so we'll keep it consistent. I'll say public static credit card array adapter. That'll be my CC custom adapter. All right, so I'm going to create an instance of my specialized array adapter here that I just built. We'll do this inside of main. So I'll say core dot, I name it CC custom adapter, is equal to a new credit card array adapter, passing it my context, passing it my R dot layout dot, and then I'm going to pass it my special custom credit card row that has my 4 text views in it. And then the last thing I'll pass it is not my credit card strings. I'm going to pass it my collection of credit cards. Core dot the credit cards. Because this custom credit card array adapter, he knows how to work with credit card objects, not string representations of credit card objects. That make sense?
So the CC adapter and the credit card strings, core variable are both irrelevant now?
They're irrelevant for this, yeah, right now. I'm not going to use them anymore. So I'm going to comment this guy out. And then the last thing I need to do is, when I'm dealing with my credit card list view, the adapter I'm going to use for him is my new super adapter. Make sense? Go ahead.
Do you have a GitHub repo that you'll put this up into?
Yeah.
Okay.
I just keep pushing it to the same one.
I don't know if is the link in Blackboard. I can search for it, but I have AUD, so sometimes my attention to detail.
I thought it was. If not, before we take our next break, I'll push it real quick. But you can always, my stuff is just under M. Littman on GitHub. You can find all my code up there. It's all public.
I went for Mike Littman, and I found a professor at Rutgers, and I was like, well, that's not quite our Mike Littman, so.
It's crash. Let's see. What is he upset about?
So just one word, Mike Littman on GitHub.
Oh, I think so, yeah. And I think it might be M. Littman.
Are you still using arrays?
Yeah, right now I am. GetName on null object reference. Oh. I meant to do this because we talked about this at the beginning of class. We still have that same problem. Yeah. I have an empty array of credit cards. Yeah.
Great segue for you.
Okay. So, just for our quick little fix here before you start, the same thing I did before up here, I need to go ahead and be able to create a whole bunch of empty credit cards. All right, so what I'll do is, just as a quick convenience, I'll come into my credit card class here. I'll write another little constructor, public credit card, that takes no parameters and just sets this dot name equal to name, this dot start date equal to start date, this dot min spend is equal to -1, this dot bonus or point bonus is equal to -1. So that'll be like a default credit card. So if I call the credit card constructor that takes no parameters, it'll just fill in those 4 things with sample values. say core dot the credit cards at bucket I is equal to a new credit card. So that'll fill it up with a bunch of blank ones to allow it to run for now. Why is it so did I zoom on this guy? You should have really screwed with me. You should be like, look, what man? It looks fine. It looks good. I don't know what you're complaining about. All right, so we can see that these are specialized rows up here. And then I'll go and add a credit card. So we'll call this guy. I'll go and add a credit card here. We'll call this guy Chase something, blah something, 3,000 and 50,000. I'll hit submit. Oh no! What did it do? Add credit card. Oh, my CC adapter doesn't have a value. This all has to do because I have two adapters there, so I want this guy to be core dot CC custom adapter. All right, so there's my special row there.
Must be the raccoons.
Yeah. We did have a problem this last summer in this room with a wasp nest in here. It's up in one of the air conditioning vents.
Nice.
Because we were in here doing VR stuff and we kept getting attacked by wasps.
It's so realistic.
It's just it's like, man, that hurts. Okay, so let's take a 7-minute break. Here, let me push this for you real quick, and I'll show you what the link is, and I'll put it up on the... So whenever I make changes, I'll just go ahead and do commit. I'll say added custom array adapter. And we'll do commit and push.
I found your implement, so.
Okay.
Thank you.
So this guy will be up there, but I'll put a link real quick in.
That's great, man. Yeah, no, there's a Mike Whitman on GitHub, and he's CS Profit Routers, and I was like,
Yeah.
that's not our Mike Whitman.
Actually, you can do it on your phone.